Again, this is Sir Don, and we will be discussing about finding the domain and then the range of a function. At the end of this discussion, you are expected to find the domain and the range of a function. So you will be encountering several terms in this lesson. The first one is a domain. This is the set of all first coordinates or the x coordinates, abscissa, or the values of x. Each element is the domain is also called pre-image. The other term is what we call the range. This is the set of all second coordinates or the y coordinates or the ordinates. This is actually the y value or the values of y. Each element in the range is also called the image. So if you have a set of ordered pairs, the second element there, all the second elements are called the range, and while the first elements are called the domain. This term is what we call undefined term. So this is a number is undefined when its denominator is 0. So basically this is not a fraction because a fraction must have a numerator and denominator. The denominator must not be equal to 0. A value of x that makes the function undefined is not part of the domain. So this one is undefined. As you can see, you have here 0 as the denominator, so the value of this one is undefined. Another one is x squared over x minus 1. So this is a rational expression. So if you're going to replace x with 1, this denominator will become 0. So this is undefined if x is equal to 1. So we call this, the value of this one is undefined if x is equal to 1. Another term is what we call the imaginary number. A number is imaginary when the number under the square root sign is negative. The values of x that will make the function imaginary are not part of the domain. Let's say for instance, we have here the square root of negative 5. So the value of this one is imaginary. So there is no square root of a negative number, therefore that is imaginary. And we have also the square root of x minus 6. The value of this one, or the square root of x minus 6, will become imaginary if the value of x is less than 5. Less than 6. So if this one is 5, that will become negative 1. So since we have no square root of negative 1, then that will become imaginary. Let's solve some series of mathematical problems involving the concepts that we had, the terms that we had discussed. So we are going to find the domain and range of a given function. Okay, so we're going to find the domain and range of the following diagram. So we're going back with the relations or functions. This is actually a function, so we can represent a function using a mapping diagram. This one is a mapping diagram. So you have these first variables, first values of x. So these are the first element. These are the second elements. Okay, so x and y. So the domain here are, so 1 is paired to 5, 2 is paired to 4, 3 is paired to 4. So the domain here, using the numbers used in the first set, we have here 1, 2, 3. Then here we have 4 and 5. The same with this one. The x elements are 1, negative 1, 2, and negative 3. And the y elements are 8, negative 4, 0. So these first elements are being paired to negative 4. So therefore the domain is negative 1 to negative 3, and then the range is negative 4. Let's have the domain for the table of values. Domain and range for the table of values. Okay, we have the first table, then the domain here. Again, the domain is the set of all x values. So we have 1, 2, 3, 4. Then the range is the set of the y values. We have -2, -1, 0, and +1. Second one, we have the set of values for x, 1, 2, 3, 4. Then the set of values for y, that is 1, 4, 9, 16. So writing the domain, we have 1, 2, 3, 4, and then the range is 1, 4, 9, 16. Next one, we have finding the domain and range of the following sets of ordered pairs. So we have the first, we have -2, 4, -1, 1, 0, 0, 1, 1, then 2, 4. To find the domain of this set of ordered pairs, all you have to do is just get the first elements. We have -2, -1, 0, 1, 2. That's it. -2, -1, 0, 1, 2. And to find the range, you're just going to write all the y values, and that is 0, 1, 4. Our second example, we have 1, 1, 2, 8, 3, 27, 4, 64. To get the domain, just get all the x values. Then to get the range, just get all the y values, which are 1, 8, 27, and 64. Next one is finding the domain and range of the following graphs. We have the first one. As you can see, we have several points here, 6, 1, 3, 3, 0, 5. However, this one is actually a straight line wherein it opens downward and this one is open upward. I mean, this one is extending downward and this one is extending upward. So the arrow here is, it means that this line is extending downward and this line is also extending upward. So we have also here several points. These are just some named points. So these are just some of the points that are being named, but we're not just going to write all the x values here, because as you can see, there are other points here which containing x values, and there are also y values there. Therefore, we can say that all numbers here being passed through by this line are all real numbers containing, if there's 1 point for x, there's a corresponding value for y. So since we cannot count all this, but the points here are actually real numbers, so the domain here is actually a real number, as well as the range is also a real number. Then we have the second one. So from this point, that is 2, 1. So the domain here is that the arrow symbolizes an extension upward, and then here we have an extension upward also. If there is one value for x here, there's a corresponding value for y upward. Let's say -2, corresponding value for y will also being passed through by the arrow here, same to the positive number. So therefore, the domain here is all real numbers. But the range, it only begins with, looking at the y-axis, it begins with +1, then upward. You cannot, or this graph does not pass through 0 on the x, or I mean the y-axis. It begins with 1, then upward. So since it begins with 1 upward, so the range of that for all values of y is x is greater than or equal to 1. I mean, y such that y is greater than or equal to y. So let's solve the equation of a function and finding its domain. So here we will be discussing about the function and how are we going to find the domain. We'll be encountering a symbol like this one. So we call this one as a function notation. F of x. This is read as f of x. This one is f of x, used to define a function. The symbol f of x is used to denote the value of the function f at a given value of x. It means that we can just say that f of x refers to the y value. So f of x refers to the y value if you're going to substitute a certain value for x. Example, what is the value of the function f of x is equal to 3x minus 1 if x is equal to 2? So here, we're just going to substitute here x with positive 2. So we have here the given f of x is equal to 3x minus 1. Then substitute the variable x with 2. Then simplify. Then we have the value for function of x, which is wherein x is equal to 2. And the value of that one is 5. Finding the domain of the following equations of a function. So here it is very difficult because compared to the graph, we can easily identify by visualizing the graph. But here, there are some computations that involve to find the domain. Just like function of x is equal to 3x. As you can see, whatever value that you're going to replace x here, there will be a corresponding value for y. So these values can be a set of real numbers. So therefore, the value for the domain or the domain of this one is that x such that x is an element of R or is an element of a real number. Then the range is also a real number. Number 2 is we have function of x is equal to x squared. So whatever value that you're going to replace x here or being replaced to x, there will be a corresponding value for y. So whatever value it is, any rational integer, whatever value it is, and that is actually a set of real numbers. So therefore, the domain is that x such that x is an element of R or element of real number. Here, going back with the definition of imaginary, the square root of a certain number here should not be negative. So what would be the value of x here so that to make this one negative? So our concept is that the value of this one, that is the square root of x minus 2, should be greater than or equal to 0. Because if this becomes, let's say for instance, what are those values that will replace x to make this one 0 and above? Then compute, square both sides. Then we have x is minus 2 is greater than or equal to 0. Then x is greater than or equal to 2. So it means that if we're going to replace 2 here, or x with 2, that this will become 0. And square root of 0 is 0. And all values of x or greater than 2, let's have 3. 3 minus 2 is 1. Then square root of 1 is also 1. So there is a value. So let's say for instance here 1, x becomes 1. 1 minus 2 is negative 1. So that is imaginary. Therefore, the domain of this one is x such that x is greater than or equal to 2. As example, we have function of x is equal to x plus 1 over x. So take note that this one is actually a rational expression. So we have here x. This x here must not be equal to 0. Because if this becomes 0, the value of this fraction becomes undefined. So therefore, x is a set of real number, is an element of a real number, then x must not be equal to 0.